is Greg Orloff, IoT World, and I'm here with Christian Piechnick. And Christian is the CEO of Wandelbots. Welcome, Christian.
Hi, thanks, Greg, for having me.
Oh, you're welcome. I look forward to the conversation. We're here to talk about robotics, obviously. I think when we look at robots are not new, but when you look at some of the capabilities and the transformations that have happened over the recent history, let alone kind of the past several decades, what do you feel is the true potential of robotics today, and how can it help solve some of the challenges that we're seeing in global labor shortages and some other aspects, Christian?
Oh, that's a great question. Because um, what the number of robots we're seeing today compared to other key pillars in technology is comparably low. So we speak about 3.5, 4 million installed robots today. I think the full potential in terms of install base is 10, maybe 100 times as big as we see it today. Robots are mostly seen in industrial manufacturing, and if we speak about industrial manufacturing, most of the times in what's called um, low mix, high volume production. So companies that produce very uniform products, which have a very long produce those products over a very long time, because robots traditionally are not very well known for being extremely flexible, adaptable, and very complex to handle. So you have to have a giant skill set in your team to basically work with robots. And now something is changing. The whole industry moves towards a more softwareization on shop floors. New capabilities allows us to apply reinforcement learning, large language model, everything that comes from the AI sector. So we can speak about what's the key unlock there. But um, I think robots will change our world in the next 30 years, as PCs and smartphones have done that in the last 30 years. And right now is the time where this whole, let's say, rise of robots is beginning.
You touched on an aspect of something I want to peel back a little further. Every robot speaks a different language, so to speak. We're talking about software and kind of that aspect of the operation. Is the future about, one shared standard, do you think, or tools that make those differences disappear? Where do you see that going, Christian?
And that's one of the central aspects, right? So the basically robots are, of course, there's metal and gears and cables, but
Right.
mostly what's really creating the value is software, and this software for all of the robot OEMs comes from the 80s. So there has not been any major significant innovations from a software level in the past 30 years. And every robot manufacturer brings in their own proprietary technology stack, interfaces, control paradigms, user interfaces. Everything's like very vendor specific and proprietary. This makes it extremely challenging to use them at broader scale. And the change, what we're currently seeing first by yeah bringing robots to a modern software stack is one of the key unlocks when it comes to the significant increase in install base. So today, finding a robot programmer is extremely hard. Finding people that can program a Fanuc or KUKA or ABB robot or whatsoever, very specific to the individual robot maker, but also the skill set those people have to have is very specific. So opening up, let's say, the modern world of software development to robots immediately increases the available workforce, the available tools that can be used, and also the contributions made in other areas directly applicable to that industry.
Do you see that as kind of a necessary mind shift, you think? I mean, is this the way that people are looking at it? Is that starting to happen, do you think, or are we still slow on the uptake?
No, I am. So, of course, it's a rather conservative, slow-moving industry overall. And we are working in this industry now for many years. But something has fundamentally changed. I think there is still a giant gap in, especially on enterprise level, when we look at IT and OT. So those two worlds between the guys that work in IT and basically work with software the entire day and the folks that are working with production machinery, those two worlds basically traditionally live completely disjoint. So there is different set of tools on technologies on mindset, but and the big blocker the entire industry had was those two worlds not coming together, and this is now changing. Good question. What's leading to this change? But I think the entire world just saw what's possible with ChatGPT, LLMs, in our like nowadays in our daily lives. Think of so there is a nice use case. McKinsey and Microsoft have published last year where they were applying AI agents to email forwarding in McKinsey. Sounds like a super boring case because all what they have implemented is finding the best suitable partner within McKinsey when a client request comes in, generate a report for that person, and so on. At the end, what in business outcomes, this meant a double-digit percentage in increase in client onboarding time and reduction of administrative overhead. Think
That's
about
significant.
yeah, think about what AI can do to shop floors, which are so far away from being planned and operated optimally. And I think this is where people are opening up and understand that digitization and especially softwareization on shop floors is necessary to also benefit from those double-digit efficiency gains.
You hinted at this, and I know Wandelbots has worked with a myriad of different, fairly large and recognizable companies from the automotive sector to, mining and other robotics. I mean, what are some of these organizations? And I don't expect you to name names, but what are they doing differently with robotics that other folks could possibly learn from?
Mm, I think so. So typically, our customers are large enterprises, which also I would say, if I look at our main customers, are fairly familiar and experienced when it comes to robotics. But as there is a big driver in the market to which pushing people to bring more flexibility into their production processes, be able to react to market changes more quickly, reduce cost, and become more effective. Those are the main drivers, basically. And what those companies, I can name a few. So we're working with the big automotives like Volkswagen, for instance. We're working with big automotive suppliers like Tesla, so like Schaeffler, for instance. We are and Schaeffler is maybe one of the lighthouse examples we see out there in the market because they're a very experienced company when it comes to automation and robotics, but they also see that the technologies which are available these days allow them to become much more efficient and faster and more flexible by just adopting what's there. And this requires more progressive thinking, take risks, and also basically change the status quo of how this company has done things in the past 20, 30 years. And I think technology is available. It's more the cultural change and the ability to also take some risks associated with that that's driving it. But I think the result speaks for themselves. So if we speak about, for instance, aspects like use AI for
Mhm.
optimization. So take a production cell, which is already there. And then the question is, what can I do to make that cell produce more products in the same hardware setup just by optimizing the software part of it? And the first step in order to get there is to make this world, let's say, reasonable or available to AI. Very concretely, this means like creating a digital twin in terms of how the cell is being set up, what components are in there. And here we heavily partner, for instance, with NVIDIA, which have a bunch of great simulation capabilities with NVIDIA Omniverse. So once you have digitized this, then it's simply being able to apply proper simulation and apply AI for finding a better control mechanism for that cell. And we have seen with our clients, let's take an example of Fränkische Industrial Pipes, which is another automotive supplier. Here we could drive efficiency gains which are almost 60%. And that's simply by running an algorithm and then having a production output increase of an already existing cell without any hardware reconfigurations of up to 60%. And that's gigantic when it comes to what that means in terms of revenue increase and even profit increase of those companies.
Yeah, 60% improvement is huge. That's that's a definitely that's a large percentage to see that kind of impact. Yeah, it's interesting when you look at the digital twin capability and technology in general for, I'll call it brownfield for lack of a better term, or existing facility infrastructure. If you had the opportunity or the chance to build a factory from scratch, if we talk about a greenfield type of an opportunity, how would it differ from ones you've seen so far? Anything that you would incorporate differently?
Yes, and here, yeah. So in order to give a short answer, right? Um, I think we are working with technology to make robots, yeah, easier to use, more flexible, and much cheaper in cost of operations across the entire life cycle. So we call those three phases: plan, build, and operate. Which means like from the first moment you think about robots in your factory, or maybe automating a step which previously were done manually, from building it, so construction, setting things up, testing things, and doing commissioning until operations. So our ambition is to be helpful in every single step of the process. Um, in Greenfield, so the fact is that the hardware which we see being deployed on shop floors is really capable. So it's not so much that we, in order to, let's say, modernize, make our shop floors more flexible, be able to react to changes much quicker, we would need different robots or different setups, or, um, the hardware setups we have here in Brownfield today, they are already good enough. What's missing is a layer, a software layer, which makes those machinery available to state-of-the-art technology like LLMs and reinforcement learning, make it available to software developers, which get trained different tools and skills at university or in their jobs today than what's required to program a robot, for instance, today. And unlocking this world of software engineering to robotics with the same tools and the same languages which are used, for instance, to build autonomous cars, or even like program our TVs or apps you will find on your
Right.
iPhone. That's exactly unlocking so many capabilities, decreasing cost for the solutions, that the basically install base in terms of hardware is not the blocker. It's the software infrastructure this hardware operates on.
Great. Wait, I appreciate the insights, Christian. Thanks so much for sharing with us today.